A K Sinha, sir. So shall we move towards for the wonderful session which is going to lead by Professor A K Sinha, sir, who will speak on groundwater and climate resilience for the agriculture sector. Professor Sinha has extensive academic and applied expertise in the water resources and agricultural resilience with a strong focus on the climate adaptation. Professor Sinha, may I request you kindly proceed with your enactment session with your blessed word, please.
Namaskar. At the outset, I'm highly thankful to Dr. Jain for this invite to participate in this very well organized water summit. And it is a great pleasure for me to share some my viewpoints on the given topic, groundwater and climate resilience. Next, please. Yeah. Okay, this one. Yeah. This is, I want to go back to our ancestors with all due regard, because their warning was there. Ability to see, hear, and speak are useless in the absence of adequate water. Water is the basis of life. Most life born in it and live in it. Oh, what a stream, come near me, you are elixir of immortality. This is a translation from the survey there, and it shows that the concern for the water was there right from the down of the human civilization. And if you would have heeded this warning, probably would not have landed in the crisis which we are facing today, particularly the water crisis. Well, this is a very primary image which shows the importance of the groundwater. We have only 3% fresh water available. Of course, it is a water planet, but only 3% water is fresh, and out of 3%, 79% is logged in ice caps and glaciers, 1% runoff in a river and lake and other superficial water bodies, and remaining 20% is groundwater. So that way, groundwater constitutes the major source of fresh water available to us on this planet. So why groundwater and climate resilience? I'll not talk much about the groundwater importance. We know that 99% of all liquid fresh water on Earth is groundwater. So we are facing the climate change phenomena. Since industrial revolution began, that time we had, as per the reporting, around 250 ppm of carbon dioxide in the atmosphere. Today we have around 400 ppm carbon dioxide. And this carbon dioxide is again added with methane, nitrous oxide. Though the carbon dioxide has 1 unit of climate warming forcing potentiality, but in respect to this carbon dioxide potentiality, the methane has around 21 times climate warming potentiality, and so nitrous oxide varies. As per the different reports of the IPCC, it varies from 250 to 325. So you can understand how, and they are supposed to cause warming, and we are facing, there are many evidences that warming is there and that climate change is taking place. Groundwater, of course, it is invisible, but it is backbone of India's food system. If you take, this is the figure, sorry. the right side figure you see, out of the 10 countries which are drafting the groundwater globally, the highest 10 countries, India is topmost. India is drafting more than 100, 250 cubic kilometer of water, and we are producing less than what China or USA is producing. So somewhere we are not able to manage our resources, rather we are using more these valuable resources. So, you have seen earlier, speakers have shown and expressed that how the climate change is affecting the rainfall, precipitation pattern. I mean, drought and precipitation patterns are shifting. It is not that the volume has dwindled, but there is a change in the pattern. Where there was a excess rainfall, now there is a drought. Now, where there was a good rainfall, now a drought. We are getting rainfall. You might have heard about the flood in Rajasthan, Thar Desert. Nobody heard it before 2006, when the Kwas area was flooded, and since then we are getting the flood in this part of the. Whereas the Cherrapunji used to be the highest rainfall getter, suffering from water deficiency. So this type of pattern of shifting of drought and excess influx of water, creating lot of inconveniences and primarily affecting the groundwater discharge. Yeah. So this this understanding of the groundwater climate linkage is not only is now a very development necessity, because you see, United Nations constituted, as somebody earlier speaker has pointed out, 17 sustainable development goals for development of whole world, to make the world prosper and peaceful. Out of the 17 goals, only one with more than 170 targets. I mean, there are 17 goals which have to be achieved by achieving more than 170 targets. And the goal number 6, target number 6.6, exclusively deal with the groundwater management. But it is not limited to that only. The groundwater, such achievement of other goals, like goal number 1, 2, 3, 8, 11, 12, 13, 15, 17, they are all linked to sustainability of the groundwater resources. So you can understand why this understanding of the climate and groundwater linkage is important, and how we need to sustain our groundwater in order to contribute, in order to have a sustainable development goal achieved. Though we are lacking much behind. This sustainable development goal 2030, which was supposed to be achieved by 2030, we are, behind 27 years behind. We are likely to be achieved by, 2060 or 70. So, if we want that goal to be achieved earlier, then we need to take care of this basic resource. Well, I will not, I will skip this thing because we have already time constantly there. So what climate change signal, relevant to groundwater? Rising mean temperature, high evapotranspiration. High evapotranspiration means ET is higher. So if you are getting the influx, precipitation, ET minus precipitation, that is in minus, then you are not getting any, but ET and precipitation give you surplus, then you are having the surplus water for the recharge. So that way, high evapotranspiration ultimately means losing the water. Then you have the rainfall variability. Climate measurable record by thermometer shows that temperature has gone up and going up. And another, we have 7,000 kilometer long coastal region. We have a coastal aquifers. So sea level rise. Sea sea level sea inundations, they are causing slime water intrusion and also affecting the soil, agricultural soil and the groundwater in the coastal region, in the coastal aquifer. So these are there, and we are, as Professor Dr. Jain has already shown you, that there is a lot of slime intrusion phenomena. It is because of the climate change effect. Because climate change counting not only adding to seawater because of the glacial melt and other from sources, rather it is because of the oceanic thermal expansions also that intrusion is taking place. So climate change has a very important impact on the groundwater, and groundwater dot frequency is increasing because of warming needs more water, and so you go for the more pumping. Most of the shallow aquifer, unconfined aquifer stand exhausted. So you are going more deeper and deeper, spending more energy. So these are the aspects which why we need to understand the linkage between the groundwater and the climate change and try to sort out to achieve a sustainability of the resources. The most affected area is Indo-Gangetic Plain and Peninsular Hard Rock Aquifer, or also the coastal aquifers. Because the Indo-Gangetic Plain constitutes the food basket of the country, right from Punjab, Haryana, okay, so all these areas have UP, Bihar, so they are Bengal, they all constitute the food basket, and here the impact are being felt. Even the riverine system are getting affected, because if you take the measure the water discharge, you find that it is mostly the perennial rivers are being supported by the groundwater, and groundwater level has gone down, so the perennial river also becoming, like Ganga is becoming narrower in a normal season. So, okay, so well, I will skip because the time reminder has come. So there we have to talk about the resilience. If you want to make the agriculture sustainable, because agriculture is standing at the cross, it is in between the climate change and the groundwater. Agriculture not is the victim of the excessive warming, but also it is a cause of the warming, because of the warming you are not getting the adequate volume of water for agriculture, and agriculture is also contributing towards the warming by producing greenhouse gases like methane, like nitrous oxide. So these are being produced because of our inefficient agricultural management. So we should have a very climate smart agriculture, that is called CSA, and that is again, if you want to have it, again we have to be highly dependent on the groundwater system for getting adequate irrigation, for multi-cropping system, because now we are having multi-cropping system to support multi-cropping system, but in the process the depletion is very, very high. So that has to be balanced to sustain the agriculture, to sustain the agriculture productivity, and to make it climatically adapted, and also see how our agriculture practices can minimize the emission of greenhouse gases. So I'm not going to discuss the demand side and supply side, because we have already, there is a lot of discussion about the demand side and supply side, but there has to be balance between the demand side and supply side, management, because one cannot be comprised at the cost of the other. Both have to go together. Demand side, of course, it is short-term management, and supply side is long-term management. So we have to think both the management that perspective, and we should not ignore the supply side management for sake of demand side management. One thing more which we are finding, you see, the three major user sectors, agriculture, industry and domestic. What we need to do, look, whatever we are drafting, for example, whatever water intake we are going to have, I mean, we are taking for the agriculture, we are not using totally. You see, so you see, there is a gap. This much we are wasting. Whatever we are drafting, we are not using that much. Rather, we are using less and drafting more. So that the gap is being wasted in all these sectors. So that need to be taken care. If we are talking about the resource conservation and resource sustainability, then we have the various government policy framework which you have known. One is NITI is very important, which is being practiced in Kerala and Goa, with very the Atal Bhujal Yojana have been already talked by the Dr. Dave. So what all these government schemes speaks about, it is a sort of shifting from supply centric engineering to the community centric governance. So we have to be more and more dependent on the community. And look, there are various adaptation technology which we can practice and which are being practiced in a different part of the world, also in India. So suppose if you have to have a diversion of the water supply, then you have to go for the borehole, tube well, and then prevention of emergency or extreme weather event. For that, you need to go for the borehole, tube well intervention, desalination. Again, for the water diversion of water supply is required. So these are the 11 technologies which are used for the different purposes. You are going for the water conservation, you are going for the storm water control and capture, you are going for the required water quality demand to meet out. So for that, there are different technology which need to be adapted for mitigate for sustaining the resources. Then this is very important. Nowadays, this newer technology, we have to take into consideration the newer technology like digital AI, geospatial innovation, because India also and world also, the AI has started using for the making the predictive models for understanding the presence and absence of water in a particular basin or the level of groundwater in a particular basin. So if that information we have, if that is supplied to the community, probably community will be more aware to plan the agriculture accordingly, whether they have to go for high water demand crop like rice, wheat, or they have to go for the low water demand crop like millet and other things. So that is possible only when we have very precise information which has to be provided to community. So I have not discussed the case study, all that time is there. So pathway for the scale marked with the scientific citing. Of course, that for that also there is a guidance from by our ancestors. Water which came down from heaven, those spring of their own, the bright and pure water that finally reached the sea, made the divine water, may protect me. So the water which goes to the sea, if that is tapped on land, that can help us. This is one of these are the findings. Sorry. These are the findings in different journals. So there are 33,000 cubic kilometer water which are losing, world is losing to the sea annually. If the 8% of it that is stored on the land, that comes to 2,500 cubic kilometer, then our water problem will be solved. In India, as per the one of the IWMI findings, we are losing around 1,150 cubic kilometer water to the sea. If that water is again harnessed on the land, then probably our water resource problem will be solved. Then in Rajasthan also, this is one of the, you see, this is one of the panel diagram showing the aquifer in Rajasthan. Most of the panel, they have the saline aquifer. So these aquifer are saline, but we can also use the space for recharging the fresh water in rain water. because the rainwater being of low density and the saline water being high density, the low density water will flow toward the high density water, and this can be abstracted in time of emergency. Similarly, many units are not mappable, but if you go for scientific studies, this is one of the studies carried out in Tataramgarh area, and you find that there is a passage of groundwater over the saline water, so there is a groundwater saline water interface. So this type of information need to be provided to community farmers who can tap the groundwater and the saline water groundwater interface. That water can be used for salt resistant and salt tolerant plants. So what we need, that is partnership. And that partnership very important, as somebody has also said, that partnership on to have various various levels. There is community partnership, stakeholder partnership, as Dr. Dave said, functionary and the professional partnership, so that they could understand the problem and they could implement. Then the research and training should be emphasized. It should not be that a particular community is trained, but the community should be trained in such a way that it should act as a training for trainers. They should further train the people, and so that the knowledge. Bhujal Jankar, number of Bhujal Jankar increases, and everybody become a contributory in the sustaining the water resources. So all these partnerships, all these activities may ultimately, will bring attitudinal change. So resource management is a matter of attitudinal positiveness. We should have a positive attitude, and this positive attitude can come through partnership, through education, through reliance, through trust, in developing trust, and bringing in ethical practices. I was shocked there. Everybody might have heard one of the speaker said that if he asks somebody to take the water senior, his SCR will be, it will reflect in his SCR. This type of attitude will not help in sustaining the water and not encourage the professional and the worker to work committedly with all intelligence and diligence, make the water sustainable in the face of the climate change, which is going to make the resource availability more complex and complex. Thank you very much.